Okay, folks, this week we're going to continue with what we started at the end of last week, which is still working with polynomials, but instead of multiplying them or adding them or subtracting them, we're actually going to be factoring them, which, as we saw at the very end of last week, factoring means that you're going to actually be breaking this polynomial up into factors. So the first way we've been doing this, we started at the end of last week, is to use the greatest common factor, which, again, you can refer to the video from last week, but I'm making a new one just to kind of refresh your memory and help with a little bit more. We look at all the terms in the polynomial, and we look for what is the biggest factor that all the terms have in common. So we start with this one here, which is a trinomial. I look at the numbers first. So I look at 40 and 32 and 16. And I'm thinking about what's the biggest number that goes into 40, 32, and 16. And that would be 8, right? You want the biggest number. Like 2 goes into all of those, but it's not the biggest number. That's why we call it the greatest common factor. So you want the biggest number that goes into all 3 of them. So that would be 8. So I'm going to put that down, 8. Now I look at the variables, and x to the 6th, x to the 5th, x to the 3rd. What is the largest amount of x's that they have in common? And it would be x to the 3rd, right? Because this one has 6 and this one has 5, but this one only has 3. So the amount of x's that they all have in common is x to the 3rd. So I'm going to take that out. All right? Now, after that, I have to figure out what is the remaining polynomial. And the way I do that, like we saw last week, is we divide each of the terms of the polynomial. We divide by the GCF. And this is why we worked on division last week. So you have your GCF. This is what they all have in common. And now to get the remaining polynomial, you divide each of them by that GCF. So 40 divided by 8 is 5, and x to the 6th divided by x to the 3rd is x to the 3rd. And then here, 32 divided by 8 is 4. X to the 5th divided by x to the 3rd, subtract the exponents, would be x to the 2nd. And then lastly, 16 divided by 8 is 2. And x to the 3rd divided by x to the 3rd completely cancels out. So there'll be no variable part with the 2. So this is our final answer right here. So like I mentioned last week, it's a little weird to leave it like this because we're so used to distributing out. But here with these problems, we're actually doing the reverse, where we're looking for what they have in common, pulling that out, and then writing the remaining polynomial. Okay? Well, let's just do a few more, and we're going to practice this today and tomorrow. Okay? So let's say we had this polynomial, 28x to the 4th. Okay? So once again, I want to look at the polynomial and I want to figure out what is the biggest factor that they all have in common. So we start with the number. So you look at 28, 36, and 24. What's the largest number that will go into all 3 of those? And if you think for a minute, you figure out that it's 4, right? 4 is the biggest number that goes into all 3 of those. So that's going to be the numeric part of our GCF. Now you look at the x's, and what's the largest amount of x's that they all have in common? Well, this one has x to the 4th, x to the 3rd, x to the 2nd. So 2 x's, x to the 2nd, is the most that they all have in common. All right, this one has 3 and this one has 4, but this one only has 2. So I can't take out any more than x to the 2nd. And now, once again, I divide to get the remaining polynomial. So I divide. Right? 28 divided by 4 is 7. X to the 4th divided by x to the 2nd is x to the 2nd. Now we have a minus in between. You just pay attention. Whatever symbol is here is also going to go there. 36 divided by 4 is 9. X to the third divided by x to the second is x. And then another minus. 24 divided by 4 is 6. And x to the second divided by x to the second completely cancels out. So this would be our factored answer with our GCF up front and then our remaining trinomial right there. Okay? So this is our process of factoring using the GCF. Okay? Let's try one more together. All right, so why don't you try this on your own? Pause the video, try this on your own. When you're ready, play it, and we'll come back and we'll see how you do. Okay, so now we're back. And so, again, we're trying to factor this using the GCF. So you look at the numbers first, 24, 9, and another 24. So you look for what's the biggest number that will go into all three of them, and it should be 3. 6 goes into 24, but doesn't go into 9, so we want a 3. Now you have 2 different variables there. So when you look at the x's, you have x to the third, x, and x. So they all have an x in common. And now you have y to the second, y, and y to the fifth. So they all at least have one y. Okay? So your GCF is 3xy. And now you're going to divide everything by that GCF. Right? And get your remaining polynomial. So 24 divided by 3 is 8. X to the third divided by x to the first will be x to the second. And y to the second divided by y to the first, you subtract the exponents, that'll be y to the first. Plus 9 divided by 3 is 3. Here, x divided by x cancels out. Y divided by y cancels out. So there will be no variable with the 3. It'll just be the 3. And then minus 24 divided by 3 is 8. X divided by x cancels out. And then y to the fifth divided by y to the first is y to the fourth. So there's no x term there, or no x variable, because it divided out is just y to the fourth. So this is our final factored answer. Okay? So hopefully these few problems helped you a little bit more along with what we did last week. So go look at the video that I did last week. Look at this video. Follow along. Try to see what I'm doing. Try to get the answers that I'm getting. If you're having any trouble, email me with specifics. Mr. Godra, on this problem, I don't know why you took out an X or why you took out a Y or whatever. So if you email me with specific questions, then it's really easy for me to get back to you and help you. Okay? All right. Have a great day.